Okay, so we have kind of a blank slate here. They're having a raised bed, so we got a little bit of room on this wall panel. So I made this panel. We're attaching it with 1/4-20 machine screws through some cross nuts that we put in. Basically kind of figuring out where all the components are going to go and everything. So we figured these were going to be mounted to the wall, so we put them where they needed to go, kind of had them all set up, and then bolted them to this wall panel. So right now we just insulated there. We're going to put it right up on the wall and fasten it, and then we could put in the wheel well cover and the other components and then start wiring things. Alright, so the only wire we're running behind this wall panel is actually from the starter battery, using the Victron smart charger. So it's DC to DC from that battery to this battery. Whenever you're driving, it'll charge your batteries back here. So that's the 12-12-30, and that requires 6-gauge duplex wires coming back. So I ran that from the front. We took off the footwell panel there and this side panel, ran this through and in this bottom little channel right here, and then through this insulation, and then that's going to poke out the wall right underneath this, and we'll just connect it there and then out to the other components. So we're trying to connect the batteries here. This is kind of ProMaster specific, so if you have a ProMaster, hopefully this is helpful. Starter battery sits underneath your feet here at the driver's seat. Before you start messing with any wires, you want to unhook the battery. So that's right here. This is the ground wire. Has a little lever on there, so just open the lever and then pull that right off and push it to the side there. So once that's off, basically there's no connection. You can open this guy, just these 2 clips. So this is just a cover for the main fuse holder here. We ran this 6-2 wire through the footwell and through a trim piece and down the side of the van that way. This is the positive red cable there. So that's going to tie into a fuse that we're going to add right there. So we'll use a mega fuse, and that would be 60 amps to protect that circuit there. And we'll use some square head bolts, which are kind of hard to find, which is why we don't have it yet. So those are going to come in from the bottom of this. So you want to use a 10mm socket on this one, or wrench, to loosen that up off of the battery post, and then take the 2 Phillips screws out of this little clip here. And once those are all off, you can loosen it up and pull it off. And then this is the negative side, which will connect to that post on the negative side of the battery. So we're wall mounted, got this nice wheel well cover going with some switches and breakers. So we're pretty much all ready to get things wired up. So I wanted to kind of explain what we have here. They have 2 Battleborn batteries, 100 amp hours each, and they're 12 volt. We'll tie those in parallel, so we'll get 200 amp hours total at 12 volts. And to charge that, there will be this charger. It's an inverter charger, so you can plug into shore power and that will charge the batteries. And then there's also the smart solar charge controller from Victron, and that will charge from the solar panels. Third way is from the alternator. That's the Orion smart charger. This is the breaker box for the PV panels, or for the solar panels, so we'll have a couple PV breakers right there for in and for out to the battery. We also have this breaker over here for our AC circuits, so that will be fed by the inverter here. So we already ran this wire from the back bumper there, so that will hardwire into the inverter charger so we can get a charge, and also that will pass through power from wherever you're plugged into the circuits. So it will charge your batteries and give you power at your outlets. And then if you're not plugged in, you just turn your inverter on and that'll go to the AC circuits and then out to your outlets. This is a switch for the inverter charger, and this is a switch for the batteries, and they're both going to be tied in to a Class T fuse, which has yet to be mounted, but going to have some wiring inside and coming out the top here. So the inverter and the batteries will both kind of share this fuse here, and then it'll go out to our distribution for DC power. So that'll be positive bus bar there and negative. And then we also have this shunt, which is tied into the battery monitor. So this is Victron BMV712, which can be mounted elsewhere, but this is the brain for it, and it connects from the negative side of your battery only, and then ties into the negative bus bar there. And then we'll ground the whole system to the chassis. Anything that's metal needs to be grounded in case of a short. So we'll have everything grounded to the DC bus bar here, the negative bus bar, and that will be grounded from the shunt to the chassis. So this one needs an equipment ground, so does this one. This one's isolated, so it doesn't. And then this one right here needs an equipment ground as well. So those will all run to here, and then also the chassis. And this thing that's hanging out, I wanted to show you too, depending on what kind of inverter charger you have. This is ground to neutral bond, so when you're plugged into shore power, you're grounded through the outlet and through the wiring. And it has a transfer switch in here, so whenever you're off shore power and switch to inverter mode, it will connect the ground in here, which is connected to the chassis. That's why the chassis ground is important. These are the breakers for DC distribution and for the battery to battery charger. So those will be tied in through here. It's also an on-off switch, but that's a thermal breaker for each of those, and this is the DC distribution right here. So that's where you would tie in all of your 12 volt loads, like your fan, your lights, water pump, stuff like that. And that's all controlled with this breaker and protected. Their layout is a little bit different than I've done past fans, and this is, you know, specific to their situation and what we have running in here. All vans are going to be a little bit different. They're actually going with a fixed bed, so I was able to use more of the wall right here, as opposed to our benches are pretty low, so we can't put much on the wall. Yeah, there's a lot of different ways you could do it. You could add a box as well, but I just chose to use the wheel well to conceal some of the wiring inside there, kind of clean things up, and you could run it behind the wall too, but we just have this one coming through the wall. But then probably going to get a battery tray or something for these to kind of secure them. So this is that shore power cable we had coming in, and I stripped it back here. I cut it to length, be tied up there, and then go through this box with the clamp connector. You could go straight in. I've been using these ferrule crimps on here though, which is nice. Basically gets all the strands into that one little sleeve, so you don't have any loose wires. So you gauge how long you need just based on the length of the sleeve on your ferrule. Make sure they're long enough though. These ones are pretty shallow in their depth, so we're able to use these little shorties. But if it doesn't work, I would just either get some bigger ferrules or just use the straight wire. So just slide that in, and they should come just about to the end there. And then you're just going to crimp it down with this little guy. So that's all that does. These are all labeled, so AC wiring, if you are unfamiliar, you probably don't want to do this yet. Do some more research, maybe ask for some help, but this is going to be, so you got 3 wires. One is your ground, this one is your hot or live wire, and white is neutral. So just make sure you're not mixing any of those up when you're plugging in here, and you should be good to go. So we're about ready to hardwire all these. So this is the shore power, and this is going to be our feed wire to the circuit breaker panel. And so this is 10-3, so it's a little bit thicker. Use different ferrules on that. And then this is 14-3. So this is 15 amps coming in, and this is 30 amps actually going out. We're going to feed these through here. Alright, so make sure you're not mixing up the input and output. That's pretty important. It's also labeled right here. So those are all in there. You don't want the insulation to be, you know, too close to that terminal, but make sure they're fully seated in there anyway. And crimp them down. Just snug them down pretty well without smashing them too hard and damaging the ferrules on there or the wires. Reminder too, we don't have any power coming in here, but if you already hooked up your batteries to this, make sure you don't have any power running through this, because you'll get ficked up. Alright, so I've tightened all those screws down. You can give them a little tug, make sure they're in there nice and tight. So we're all in there pretty good, so now I'm just going to close this guy up. So I'm going to push these in a little bit, make sure the jacket, insulating jacket, is fully inside there. Alright, so feeding this to our AC breakers, that will go out to the outlets. So we have 2 20 amp circuits that we're going to be running, and we'll probably have maybe 2 or 3 on each circuit. And this is a Square D QO load center, and it's got 2 positions there for breakers. These are not connected, so we're coming right from the top, have a jumper so you can get the power to both of these breakers. To secure all of my wiring, I've been using these zip tie mounts. In this case, we're putting it on this wood here, so I'm just going to use a screw. So after you mount that, you can run a zip tie through it and cinch it up nice. You got a sweet little mount there. So we'll do that until we get to the box. So I'm gonna cut it about here. I definitely don't want to cut it too short. Alright, so I can pull that out. And then very carefully strip this jacket off. And you don't want to cut yourself either. You probably should be wearing gloves for this. And then make sure you didn't nick anything. Everything's looking good. So I like this little guy. I mentioned this in the guide, but it's a automatic stripper. So you just close it down on the correct gauge and voila. I went ahead and added ferrules to these. So I was able to get the neutral in pretty easily. This is going to go into the hot once we get a jumper cut. And then this is for the ground. Extremely difficult to get in the ground bus bar, so I just removed it actually. And we'll just put it in just like this. And once we have all the grounds in, I could just put that right back in where it goes. I didn't have any primary 10 gauge wire, so I just stole it from a little piece of this 10-3. And this is for the jumper, so we have the hot going in to one side, and then this is going to jump it over to the other circuit. Alright, doing some of the major wiring in here. This is 2-aught battery cable, so that's going to be for the battery cables and the inverter cables. It's really cold here, so I've been using the heat gun to kind of warm this up a little bit. Just makes it much easier to strip this off. And then for stripping these larger gauge wires, I use this. This is from Angkor. I think they make a more heavy duty one, which I should have got, but these are nice. Strip it back far enough to fit all the wires all the way in the lug there. Yeah, this one does pretty good, but I feel like the heavy duty one would be a little easier to use. Basically, we want to try and avoid nicking any of these wires. So there it is, and then we could fit this on there. It's kind of fluted on the edge so you can get all the wires in there pretty easily. And then for heat shrink, I've been using this heavy wall heat shrink tubing. It comes in a long length or smaller lengths if you don't need that much. This is 3/4 thickness, so you could fit 2-aught cable in there, up to 2-aught. See how much we need. I think it's about 1.5 inches or so. So you want to have enough to cover this completely. Alright, so to crimp on these lugs, you need a hydraulic lug crimper. You could use a hammer crimper as well if you'd like, but I have found some good results with this. It's a hex die right there. So you insert the die that you need and slide it over the lug, and then you can start crimping. Just make sure you're fully seated in there, and then crimp it down, loosen that off, and there you have it. And then we're going to add the heat shrink next. Slide it over, and that's just going to cover that. And it's got adhesive on the inside too, which will be activated when you heat it, so it'll be all sealed up. So that's what it looks like when it's done. I'm going to use this to connect these two negative terminals on the battery. So see how much we need, and I'm going to cut it right there. And then we could do the same thing to the other side, and then we'll have that cable. And then we'll do the positive cable, and then we'll run them to the switches and to the shunt and everywhere else. Also, when you're making the connection with your lugs on thicker gauge wire, it's hard to twist it around and reposition it, so make sure you have it in the position that you want it before you actually crimp it down. Making some connections to the battery here. We are tying them together. Working on the positive wire right now, so Battleborn provides these little bolts here that go through the terminal. So you'd want to sandwich everything in the middle of these two washers, make sure those are on the outside. So we connected it here, got the right length to tie into the other positive post, and then we put this terminal fuse with the terminal fuse holder here. I think it's called an MRBF fuse. So this connection is going from the battery out to the rest of the system. It's coming through here, and it's going to be connected to this switch. That's going to go on that post on the input side. And then for output, it's going to come out to the bus bar, which is going to sit on top. And then for the inverter, we're taking it to this switch, so it's coming from the positive terminal of the inverter and going through the wheel well and then up to the switch here. Alright, so we're connecting the DC fuse block here, and we're using 6 gauge wire, and then that's going to a 60 amp thermal breaker here. So it's just going through the wheel well, and then I'm putting it on the back. These are panel mount breakers, so the connections are on the back, so that cleans it up a little bit. So we pre-wired everything inside of the wheel well and made all the connections. So these are both wired to those on-off switches, and these will come out through the top of the wheel well cover and connect to the fuse, the Class T fuse that we'll have up here. And then all these other things over here is the same deal. We pre-wired and connected the back of these. Alright, so we've fed all these wires through, insulated it with wool before we did that, we almost forgot. And then we made all of our connections from the inside to the bus bars and the fuse block here. Tied positive to positive, negative to negative, and then from one battery, positive out, and then this other side of the battery bank we have the negative going out. So right now I'm just attaching these, and we're going to tie that to the shunt for the battery monitor. So this is how it reads the voltages and everything for your system. It's clearly labeled battery only and load and charge side. So make sure this is the only connection to this side of the shunt is the battery and nothing else. Alright, so we have everything connected and all set up. So I want to run through and show what everything does, where it's connected to. We showed you how this is done. We actually just use it to top off the batteries. So this is the inverter charger. So we plugged in the shore power plug and charged it from that. We haven't really labeled anything yet, but this is for the inverter switch and the battery switch. So this could remain on unless you need to isolate them or work on the system at all. That's how you'd shut them off. The batteries are connected in parallel. So again, positive to positive, negative to negative. And then from each end of the battery bank you have your negative side and positive side. And this is the terminal fuse here, and then that's going to the battery switch. From the battery switch comes out here and heads to the Class T fuse. It's a 300 amp fuse there, and it's also shared with the inverter. Comes out this hole here and hits the other side of the Class T fuse. So they both share that fuse, and they have protection in between them, and that also protects the wires there. From there it goes out to all the DC distribution, so everything is kind of interconnected. So that's where all power is going to be sent to that positive bus bar. And then from left to right here, this is going to be from the solar. This one is going to be from the battery to battery charger, so you charge from the alternator. This is for DC distribution for that fuse block to run all of your DC loads, and those all come through the wheel well, but all the components are on the outside here. Charge controller for the solar is right here, and it connects here, but in between there's some protection. So once the solar comes in, it's going to go through a 10 amp breaker and out to the charge controller, and then once that processes the power, it's going to send it back through another breaker here, 40 amp breaker, and then out to the bus bar. And then this is that DC to DC charger. It connects to the starter battery, which is charged from the alternator while you're driving. These two wires came from the front there, which they're connected to the starter battery of the vehicle. The negative side comes to the negative bus bar, and the positive comes through into this circuit breaker. So once it passes through there, it's going to go back to this bus bar. So that's what that connection is. The negative side is all ran through the shunt here. This is for the battery monitor, that Victron BMV712. So another 2-aught cable directly to that. These cables are voltage sensing and temperature sensing, so that all goes into the circuit board there, and then that actually plugs into the display for the battery monitor, which runs the Bluetooth, and then you can get that on your phone as well. That connects to the whole negative side of the system. On this end, the whole system has the safety ground to the chassis on this post as well, so that one runs around here, and then we actually put it right on this piece. So we ground down the paint, so we got bare metal, and ran a 5/16 bolt through there. So the rest of the negative side is all connected to that bus bar, so that's this guy here, another 2-aught cable. This one is coming from the inverter, so directly from the inverter negative, it's going to tie in right there. This post is for the negative side of the solar panel. So once you run the solar, negative wire is going to come directly to this terminal, and then this is going out to the battery. So negative terminal out to the battery post right there, which is our bus bar, which is connected to the battery. And then this one here shares two different connections, battery to battery charger output, negative, and this one is from the DC fuse block. This is where you put all your fuses and make all your connections with your 12-volt loads. Positive cable runs through the wheel well into this circuit breaker here. That's a 60 amp thermal breaker, which then comes back to the positive bus bar right there. AC power distribution comes out the back here. It's wired with 10-3 and all the way over here to this circuit breaker. You could look at a diagram on our website as well, but this is where everything ties in up top. So this is the hot wires with a jumper, so we can get the power to both circuits. And this is a neutral bus bar, so that power in comes to the top, and the ground goes to that ground bus bar. And then for both of the wiring for the circuits, neutrals tie into this side, grounds tie into there, and then there's some terminals on the bottom of these breakers right there that you would tie into the hot. And then the whole bus bar has a safety ground as well, and that's ran just to this here. So with all these green wires, these are equipment ground, safety grounds. So anything that's metal or has that ground coming through, it's grounded here. This one is isolated because it has the negative and both negatives from both batteries, so that one doesn't need a ground, but then this one does here on the side, and then this case does as well. So those are all tied into that negative bus bar. And then for the chassis ground of the inverter, that is tied directly to the chassis here. So all those are tied to the chassis as well, but this one has more of a direct connection. Alright, so we're going to be putting the short power plug in here. On the ProMasters, I've been putting it in the back bumper area right here. So to remove these panels, you're going to need two things. You'll need a Torx bit. This is a T30 Torx bit, and then also a 5/16 little socket bit there. So you'll just need those two to get this off. And then the side panel, we have to pull it off. There's trim clips in there. So something that I would really recommend doing is getting these, not through your dealer because they're very expensive, but if you go to Amazon, we'll put the link in the description. These are just extra trim clips that you'll put on there because some of them are bound to break, and it's just going to make life a lot easier. So order those before you do this job. But yeah, I'll show you how to take these off. There we go. And so there's a few of these around. And then there's actually one behind this light. It's not behind it, but to access it, it's on the top there. You're going to need to take this light off, which is pretty simple. I'll show you how to do that. So in order to remove this light assembly off of the rear panel, it's just these two knobs right there. So sometimes they're just hand tight, so you can take it off like that. If they're really tight on there, you're going to need a 17mm socket. This one down here is a little tight on mine, so put a 17mm socket on that. Take this clip off from the outside is probably easier. Just right at the top, just put some pressure on there and you can pull this whole harness out. And that's all there is to that. So that'll give you access to this last one here. And set that to the side. So in order to remove this, you need to remove this panel. That's why you need the trim clips. So you want to use that 5/16 socket. And there's a few of them right under here. And just be careful not to strip these. I don't have the right angle there, so I'm going to use a different tool to get that one. Get yourself one of these. Super cool. Highly recommend. Alright, last screw, and I'll pop this guy off. So these trim clips, they're kind of hard to access from the inside. I just kind of rip it off. Just be careful with this trim. Obviously, you don't want to ruin the plastic, but they just pop out. Alright, so we broke just about every one of them, but that's okay because we got some new ones. So some of these are pretty hard to take out. These ones in the bottom section, if you just turn them, they pop right out because they have the oblong hole. And then with these ones, you could use trim panel removers or some pliers, rip those right out. So you just kind of want to get up behind it and pull it out like that. It's probably going to break, but that's okay. Or you can use some pliers too if they're really hard to get out. But it looks like we got all of them. And now that we took this panel off, we could access the rest of these screws here that we needed to get to. So once all the screws are removed, this guy's loose. You kind of have to pry it over this a little bit. But once you do, the whole thing comes off. So we are using this Noco power plug. Got a nice seal on it, little cap on there too, rubber seal for that. And then it has a plug on one end, but we're just gonna cut that off and use the wires that are in there to attach to our inverter. We're gonna hardwire it in there. So center it there, drill the 2-inch hole, and then pre-drill some holes for the bolts to go through. I'm using a 2-inch hole saw for the cutout. Gonna want to turn your clutch up to drill mode. There we go. Now we can feed this wire through, drill these holes. Just right in the center. Alright, that looks good. Drill these out. So we're using these stainless steel because it's outside. Panhead machine screws. It's a number 10 by, we just chose 1 inch. Flat washer. And then we'll put a lock washer on there.
Are you gonna drop every single one?
Yeah, it's hard. Alright, so thread that guy on there one day. You can stop now. So we snug down all those pretty well from the back with the nuts. So that's what it's gonna look like. And then with this, like I said, we're going to hardwire this to the inverter charger that we have. So I'm going to just cut this end off. When we go to wire it, we could strip these back and hardwire it directly to it. But this is going to go right through here. Let me show you. So this is going to feed through this right here. This is a one-way valve, so when you close the doors, air can escape. We're just going to modify it just a little bit. It should be able to still function pretty well. Alright, so it's got clips on the top and bottom, so you should be able to just pop it right off. Let's see, maybe not.
Action.
I was able to get this off with the trim clip remover, kind of just dug back in there. Just be careful with it, try and ease it out. There's actually 2 parts to the assembly, but I couldn't get the front part off. So I just took the whole thing off. It's got this little rubber seal there too, so just try and keep that intact. So I'm going to cut a little slit in there, and then one in the secondary little flap there. So we're just going to put a little slit there, and that should be plenty to fit that wire through. So I'm just going to go right in like that. So I'll have one right there, and then I'll put another one in that second guy here. Let's see if we can do it from the back. Alright, I think that'll do it. Hello! Alright, so now we can feed this through. Feed that all the way through. These also come in different lengths too, so depending on how far you're going in the van, you can get a longer length, but we just got the 6-footer. Alright, so we ran that wire through, and then anytime you want to put wiring through metal or any sharp edges, it's always a good idea to use the split loom. So I added that on there, just zip tied it tight right there so it's up against it. So this is ready to feed through. It's just going to go up through this hole and out the hole that's right above it. So you feed your hand through, and then it's probably best to have a partner, so I'm going to have Courtney pull it from the inside. We'll feed this through.
Okay, off I go. Hey. There it is. Oh, keep going? Okay.
Alright, so our wire's all fed through there. We have enough slack here to fit this guy, so I'm going to go ahead and pop this back on. Make sure all the flaps are aligned. It should just clip right in. And you're all set. So this is all pretty much ready to go. So we're going to put this back on here. Just got to give it some love. There we go. Bam! So this fits right in this piece of the bumper, like that. And everything looks like it's aligned, so I'll go ahead and put these screws back in. So we're putting these new clips in, since I probably broke all the other ones. And these are just going to slide in with this rectangular piece going vertically. There's a couple different indents in there too, so you probably just want to stick with the middle one. If you need to adjust any, you could scoot them. Feed those all on there, and then we could press this back on. So the reason why these are important is you don't want water getting in the van, obviously, and these all have these little rubber seals on them. So you want to make sure they're all in good condition. So snap them all in there, and then you can start putting it back on. There's the screws on the outsides, but these are what's gonna hold them on for the most part. So you can start on the bottom. Make sure you're popping all of these in. Like so. Alright. Sorry about that little guy, but he goes in there.